Question: show that tan inverse x plus h is equal to tan inverse x plus h uh, sine alpha minus h sine alpha whole square by 2 factorial sine 2 alpha plus h sine alpha whole cube by 3 factorial, let's write whole cube properly, by whole cube sine 3 alpha and so forth, where alpha is cot inverse x, by using Taylor's expansion or theorem, whatever you want to say, theorem. This is our question. Now, since this is an infinite series, plus so and so forth, you can see here, it's an infinite series. So the Taylor's infinite series is for fx plus h, x plus h is equal to f of x plus h, f dash x plus h square by 2 factorial f double dash x plus h cube by 3 factorial f triple dash x plus so and so forth. Now you have fx as tan inverse x. Now with f dash x, your f dash x is tan inverse x is 1 plus x square. Now the thing is, I have to break this into partial fraction. Now see, take x square plus 1 equal to 0, x square equal to minus 1, x square x is under root of minus 1. This is nothing but x is plus minus iota. So the factor is, this can be broken up into, see, x plus iota and x minus iota. A plus b and a minus b is a square minus b square. Now I square is nothing but minus 1 minus this is nothing but plus 1 x square plus 1. So this can be written as 1 upon x plus iota into x minus iota. There is no problem about this. Now इसको हमने ऐसे करके तोड़ा, x square plus 1 को 0 माना, x square को minus 1. मुझे partial fraction में तोड़ना है इसको. X is equal to under root of minus 1. This is x is plus minus iota. So x plus iota or x minus iota, a plus b or a minus b होता है a square minus b square. I square is always minus 1. So I square minus 1 होता है, तो यहाँ पे minus 1, we put minus 1 here, minus 1 रखा, minus plus, that's the thing. Now use partial fraction. F dash x is equal to 1 plus x square is equal to x plus iota into x minus iota. This can be written as a x plus iota plus b x minus iota. Now you have your partial fraction. See, first you compare this. See, this 1 upon x plus iota, partial fraction. We are doing partial fraction. हम partial fraction कर रहे हैं अभी. Is equal to a cross multiply, take LCM, x minus iota plus b x plus iota upon x plus iota and x minus iota. Here it is x plus iota and x minus iota. Now you cancel these two sides, no problem. 1 equal to a x minus a iota plus b x minus plus b iota. Comparing the coefficient of powers of x on both sides we have, look here, this here. So ax and bx, this is 1 equal to, let me write 1 plus, just a minute, let me write 1 plus 0x. 1 लिखो या 1 plus 0x लिखो, एक ही है. 1 plus 0x is same as 1 because you are multiplying with 0. So write a plus bx then plus b minus a iota. So a, comparing these two, a plus b is 0, compare करके a b minus a iota is nothing but 1. That is nothing but a plus b is 0 and b minus a is 1 by iota. इसको नीचे डिवाइड कर दिया. Divide it down. Now take simultaneous solving. This is a and a cancels out. 2b is equal to 1 by iota. So b comes out to be 1 by 2 iota. And from here, a is minus b. A is minus b. A is minus b. Okay, minus b. A is minus b. So a comes out to be, wait a minute, a comes out to be minus 1 by 2 iota. A comes out to be this. Put a and b here. Put a and b in this f dash x. Put here. यहाँ पे put करो. So this becomes f dash x. F dash x becomes a is minus 1 by 2 iota x plus iota and plus 1 by 2 iota b, the value of b, into x minus iota. Take 1 by 2 iota out, f dash x, take 1 by 2 iota out, then this becomes x minus iota minus 1 upon x plus iota. Now take the derivatives on both sides. Take the derivative, second derivative. This is x. So f double dash x is equal to 1 by 2 iota. Now इसको treat it as 1 upon x. 1 upon x derivative is minus 1 upon x square. So take the derivative minus 1 upon x minus I whole square, and then this chain rule with this you will have 1 only, no need to write. वहाँ chain rule से 1 ही आएगा, कोई मतलब नहीं होता. अब इसका आएगा minus 1 upon x plus. This will become x plus iota whole square. Now see one thing. We will go for the third derivative. See, third derivative is 1 upon 2. Rather do one thing. Instead of doing this way, this is bit tiresome. This is bit problematic this way. Instead of doing this way, I do one thing. I change this format. I change this complete format. मैं इस format को पूरा change कर देता हूँ. Now f dash x can be written as 1 upon 2 iota. Write this as x minus iota to the power of minus 1 minus x plus iota to the power of minus 1. Take the second derivative. Now this will become 1 by 2 iota minus 1 x minus iota minus 2 minus 1 x plus iota minus 2. Take the third derivative of this. Third derivative, 1 by 2 iota minus 1 minus 2 x minus iota minus 3. Then this minus as it is minus 1 minus 2. Then you have x plus iota to the power of minus 3. Now you have this. You can write this like this. See, in the third derivative, 1 upon 2i. This is, there are 2 minus 1 to the power of 2, and this is 1 into 2. This is 1 into 2, and this is x minus iota to the power of minus 3. Put this minus as it is, and here minus 1 to the power of this minus and this minus square, and then 1 into 2 is 1.2, and this is x plus iota to the power of minus 3. Now see, एक चीज देखो, ये माइनस और ये माइनस हो गया माइनस 1 का स्क्वायर, 1 into 2 हो गया 1 into 2 हो गया 1 into 2. जैसे माइनस को यहाँ पे माइनस को ऐसे ही रख दिया, माइनस माइनस हो गया माइनस 1 का स्क्वायर, और 1 into 2 हो गया, x plus iota minus 3 हो गया. Now what you do is that, see, for third this is 2, for third this is, write like this, f dash this as 1 by 2 to the power of 3, 2 iota minus 1 whole square. This is 2 factorial. 1 into 2 is 2 factorial. X minus I to the power of minus 3 minus minus 1 to the power of 2, and this is 2 factorial, and this is x plus I to the power of minus 3. देखो, Listen, when there is a third derivative, it is 2 times. Let's write it in this manner. Then you will understand what I'm trying to say. Minus 1 to the power of 3 minus 1. 3 minus 1. 3 minus 1 factorial. This is nothing but 2. And this is x minus I to the power of minus 3 minus 1 to the power of 3 minus 1. And this is 3 minus 1 factorial. And then this is x plus iota to the power of minus 3 bracket. When there is a 3, this is 3 minus 1. 3 minus 1 factorial. Then this is minus 3 minus 1 to the power of 3 minus 3 minus 1. 3 minus 1 factorial, which is nothing but 2 factorial. So it is 1 less. So let us now write, इसको देख के देखो, जब ये थर्ड डेरिवेटिव है तो यहाँ पे आया 3 minus 1 और यहाँ पे आया ये 2 फैक्टोरियल था, ये लिखा गया 3 minus 1 फैक्टोरियल. 3 minus 1 कितना होता है? 2 फैक्टोरियल. ये -1 3 -1 लिखा, 2 को तो हम ऐसे लिख सकते हैं ना, और 2 फैक्टोरियल को कैसे लिख सकते हैं? 3 -1 फैक्टोरियल, एक ही बात है. तो एफ एन एक्स सीधा nth डेरिवेटिव देखो, आप सीधा nth डेरिवेटिव डायरेक्टली -1 टू द पावर ऑफ n-1 फैक्टोरियल फॉर फ्रॉम हियर, यहां से, और ये हो गया x माइनस आई टू द पावर ऑफ -n exactly, and -1 to the power of n-1 factorial, and x plus iota to the power of -n, and this is like this. So this is the whole thing like this. Now you have your own thing. Wait a minute. You have your own thing. Now let us write it in a proper manner. Fx is equal to 1 upon 2i -1 to the power of n-1 factorial upon x minus I to the power of -n. Oh, sorry, to the power of n. Sorry, this is to the power of n, to the power of n -1 to the power of n-1 factorial upon, this is also, you can see, this is also -n. So this can be written as, this is also this. So this can be written as x plus I to the power of n, bracket close. Now they have told you x is cot alpha. This is alpha is cot inverse x. This is, they have told you, cot inverse x. So cot of x is alpha. Cot of x is alpha. That means sorry. This becomes x equal to cot alpha. X equal to cot alpha. This is nothing but cos alpha upon sin alpha. This is nothing but cos alpha upon sin alpha. Put the value of x here and here and take all of them out. So now you have fnx. You take 1 by 2i -1 to the power of n-1 factorial. In the bracket you have x minus iota to the power of n -1 upon x plus iota to the power of n. In the place of x, write this. fn of x, you write, in place of x you can write this. This is 1 upon 2i, you have -1 to the power of n-1 factorial upon this. This is 1 upon cos alpha minus I sin alpha to the power of, the sin alpha will go up, sin n alpha whole n. This is whole n. This is also minus sin n alpha on the top, and then you have cos alpha plus I sin alpha to the power of n in this, to the power of n whole this. Now you have this, take sin n alpha out. fnx is equal to 1 upon 2i -1 to the power of n-1 factorial sin n alpha, and this will go on the top. This will go on the top. Cos, this is nothing but e to the power 1 upon okay, you can write this, e to the power of I alpha minus I alpha, sorry, by Euler's theorem. This is minus I alpha to the power of n minus 1 upon e to the power of I alpha to the power of n, bracket close. So now you have this fnx is equal to 1 by 2i minus 1 to the power of n minus 1 factorial sine n alpha. Then this will go to this will be like this. This will multiply inside. It will multiply indices के तरह ये under multiply like indices it will multiply inside. So this will become e to the power of I. Wait a minute. E to the power of minus I n alpha, and this will be e to the power of plus this will be I n alpha. Now fn of x would be 1 by 2i minus 1 to the power of n minus 1 factorial sine n alpha. This will go on the top, e to the power of I n alpha minus e to the power minus n alpha. Again by Euler's form. Again by Euler's form, fn of x would be 1 by 2i minus 1 to the power of n minus 1 factorial sine n alpha. Then open up by Euler's theorem से open करो इसको. Cos n alpha plus I sine n alpha minus, open up with Euler's theorem, open करो Euler's theorem से, cos minus n alpha plus I sine, wait a minute, let me write it in the little back, minus cos minus n alpha in the bracket I'm writing plus minus I sine this is plus, why I'm writing this way? I should write it directly because I know that cos e to the power of I theta is e to the power of I theta is, wait a minute, look, e to the power of I theta is cos Euler's theorem, e to the power of cos theta plus I sin theta, right? And e to the power of minus I theta is cos theta minus I sin theta. End of story. Why I am going so long? Wait a minute. Just use this concept. This is Euler's formula. Use this concept. Finish it off. So this is minus cos n alpha minus I sin n alpha. This bracket, whole bracket. Now see, when I will open this bracket, see, fn of x is 1 upon 2i minus 1 to the power of n minus 1 factorial sine n alpha. When I open up this bracket, this will become cos n alpha plus I sine n alpha minus cos n alpha plus I sine n alpha. जब ब्रैकेट खोलूंगा तो ये होगा माइनस माइनस और माइनस प्लस प्लस. This and this will cancel. So now f nth derivative of x is 1 upon 2i minus 1 to the power of n minus 1 factorial sine n alpha, and then you have into 2i sine n alpha. This is power n and this 2i and this 2i cancels out. What you are left with is fn of x minus 1 to the power of n minus 1 factorial sine n power alpha into sine n alpha. This is what I need. Now I will use my Taylor's expansion. My Taylor's expansion is, look here, it is this fx plus h f dash x, h square by 2 f double dash x, and all this stuff. So now we will use this condition completely here. So now you see, this is my formula. So fx plus, let me write down once, fx plus h, एक बार लिखने दो फिर से formula को, fx plus h f dash x plus h square by 2 factorial f double dash x plus h cube by 3 factorial f triple dash x and so on and so forth. देखो first derivative fx. What is fx? You see fx? What is fx? What is fx? What is fx? You know what is fx? Fx is what is fx? Fx is this tan inverse x. That's all. This I wanted to see. Rest all we can do from here. Here we have the formula fx, that is tan inverse x plus h. See, wait a minute. I'll show you. मैं दिखाता हूँ. देखो fx क्या दिया हुआ है? What is fx given? Tan inverse x. So fx plus h will be tan inverse x plus h. Now we will do the complete thing now. Now see. Now fx plus h, you write tan inverse x plus h. Then you have fx, that is nothing but tan inverse x plus h f dash x n equal to 1. यहाँ पे n equal to 1 है, तो this will become h n equal to 1. तो minus 1 minus 1 is 0. 0 factorial is 1. Sin n alpha, sin alpha, no problem. So this is nothing but now plus h square by 2 factorial, that 2 factorial is 2, at 2 this is plus 1 and 2 minus 1 is 1 factorial. See, minus 1 power 2, that is then 2 minus 1 factorial sine square alpha sine 2 alpha, then it is plus h cube by 3 factorial f triple dash, you put this minus 1 cube, then 3 minus 1 factorial sine 3 alpha, sine cube alpha, sorry, and then sine 3 alpha plus so and so forth. Tan inverse x plus h is equal to tan inverse x minus h sine alpha. These two have been paired up. इन दोनों को पेयर कर दिया गया. Sin alpha minus 1 का square, minus 1 square and 2 minus 1 is 1 factorial is 1. So this becomes h sine alpha whole square by 2 factorial. This 2 factorial sine 2 factorial is 2. Let me write it as 2 only. Let's write it as 2. Sine alpha, sine 2 alpha plus, and this is minus 1 whole cube is minus h cube and sine cube x, that is h sine alpha, sine cube alpha is sine cube alpha upon 3 factorial is 6, and from here it is 2 factorial is 2 sine 3 alpha plus so and so forth. So the last part is tan inverse x plus h is equal to tan inverse x minus h sine alpha. Sine alpha you can write by 1, no problem, plus h sine alpha whole square by 2 sine 2 alpha minus 2 3s minus h sine alpha whole cube by 3 sine 3 alpha plus so and so forth.